Good morning to one and all. In the previous lecture, we were discussing about the maximization using SNR, that is signal to noise ratio of the filtered signal. In this, we got the formula as eta is equals to mod of integrating minus infinity to infinity gfhf e to the power j2 pi ft df mod whole square upon n naught by 2 integrating minus infinity to infinity mod of hf square df. So now to find the solution of your numerator, we use a solution over here. We use an inequality, that is Schwarz inequality. In Schwarz inequality, we have a statement that your phi1x and phi2x, these are the two complex functions in real variable x. So it must satisfy the following condition, that is integrating minus infinity to infinity mod of phi1x square dx should be less than infinity, and integrating minus infinity to infinity mod phi 2x mod square dx should be less than infinity. Then your mod of integrating minus infinity to infinity phi 1x phi 2x dx whole square should be less than equals to integrating minus infinity to infinity phi 1x square dx into integrating minus infinity to infinity phi 2x mod square dx, taking your limit x, that is minus infinity to infinity. It is possible if and only if when your phi 1x is equals to k times of phi 2x star, where your phi 2x star is the complex conjugate of phi 2x. Now if we let us assume that your phi 1x is equals to hf and your phi 2x is equals to gf e to the power j2 pi ft. Now putting in the equation, in the previous equation, we get mod integrating gf hf e to the power j2 pi ft df whole mod square is less than equals to integrating mod gf square df into integrating minus infinity to infinity mod of hf square df. Now if we see that the mod of gf e to the power j2 pi ft is equals to mod of gf, since the mod of e to the power j2 pi ft is 1 only, so we'll get mod gf. So if we put in equation, then our eta is less than equals to minus infinity to infinity mod of gf square df integrating minus infinity to infinity hf square df upon n naught by 2 integrating minus infinity to infinity mod of hf square df. Now cancelling hf square to hf square, we will get that eta is less than equals to integrating minus infinity to infinity mod gf square df upon n naught by 2. Now if we rearrange, we get eta is less than equals to 2 by n naught integrating minus infinity to infinity mod gf square df. Now this relation does not depend on hf of the filter, but only on signal energy and noise power spectral density. Now if we see the maximum peak signal to noise ratio, here we say कि eta max is equals to 2 upon n naught integrating minus infinity to infinity mod gf square df. That is when your eta is less than equals to 2 upon n naught. So for the maximum value of eta, it will be 2 upon n naught integrating minus infinity to infinity mod gf square df. This is possible if and only if when your hf is equals to k g star f e to the power minus j 2 pi ft. Since we know we have put your our phi 1x is equals to hf and phi 2x is equals to gf e to the power j 2 pi ft. Now if we take the inverse Fourier transform, then our HOPT, that is for HT, that is for inverse response of your mesh filter. So your HOPT, that is your optimum detection, H is equals to K infinity minus infinity to infinity G star F e to the power minus j 2 pi ft into e to the power j 2 pi ft df. Now HT will be equals to, we can solve this, K minus infinity to infinity G star F e to the power minus j 2 pi